All right. Again, solve using the Gauss-Jordan elimination. So first things first, let's write our augmented matrix. So we'll have 3, 7, minus 1, 11, 1, 2, minus 1, 3, and 2, 4, minus 2, 10. All right, so first things first, I think I'm just going to swap row 1 and row 2. So that would say row 1 is going to swap with row 2. And so 3, 7, minus 1, 11, 2, 4, minus 2, 10. All right. Now I'm saying, okay, well, let's take a minus 3 row 1 plus row 2 is my new row 2, and minus 2 row 1 plus row 3 is my new row 3. Okay. So 1, 2, negative 1, 3, and minus 3 plus that. So that's going to be a minus 6 plus that's 1. That's going to be a 4, 3 minus 1 is going to be 2. That's going to be a minus 9. So that's going to be a positive 2. And so that's going to be minus 2 plus 2 is 0. That's going to be a minus 4 plus 4. That's going to be 0. That's going to be a 2 minus 2 is going to be 0. That's going to be a minus 6 plus that's going to be a 4. All right. Well, 0 equals 4. That's false, so no solution. Okay, so that was an easy one. So we always like it if there's no solution because you're done. All right, let's try another one since that was so short. All right, so this one we know is going to be infinitely number of solutions because we have more variables than we have equations. If we had four equations and four unknowns, then we could possibly get a solution. But with this one, we're going to get something that has infinite number of solutions. So that'll be a 2, a 4, a 5, a 4, 8, 1. All right, so probably first things first, let's just swap row 1 with row 2. So I'll give this 1, 2, 2, 1, 3, and 2, 4, 5, 4, 8. Now, if I'd have been paying attention, when I wrote this matrix, I could have wrote it in any order because you can put your equations in any order. I could have put this one first and then the second one, but I wasn't paying attention. And so I had to do a row operation of swapping rows. Now I'm going to say, well, okay, well, let's take a minus 2 row 1 plus row 2, and that's going to be my new row 2. So we have 1, 2, 2, 1, 3, and minus 2 plus 0, that's going to be a minus 4, that's going to be 0, that's going to be a minus 4, that's going to be a 1, that's going to be a minus 2, so that's going to be a 2, that's going to be a minus 6, that's going to be a 2. Okay. Now, one last step, we have to make that a 0, so we're going to take a minus 2 row 2 plus row 1, that's going to be our new row 1. So we have 0, 0, 1, 2, 2. Then we have a 1, a 2, that better be 0. And then a minus 2, that's going to be a minus 4 plus 1, so that's going to be a minus 3. And that's going to be a minus 4 plus that, so that's going to be a minus 1. Okay. All right, so this is x1, x2, x3, x4. So we have x3 in terms of x4. So I guess we can say let x4 equal t. So then that means x3 is equal to what? Well, if we take this over, it's going to be a minus 2t plus 2 is going to be x3. Now x2, well, we can't get in terms of anything, so we're going to have to let that equal some new variable. So, let's maybe make it a q, all right? Because if I put an s and I have a 5 in an equation, my 5s and s's look so much alike, I won't be able to tell what it is. And so then x1 is going to be what? Well, it's going to be, well, that's going to take that over, so it's going to be a minus 2q, and then it's going to be a plus 3t, and then it's going to be minus 1. Okay, so we have 3t minus 2q minus 1, or minus 2q plus 3t minus 1. Doesn't really matter. But that's going to be our set of solutions. That's going to be what it is. And this is for any real q and t, because those are two variables that we don't know. And so that's what our solution would be for this one. Okay. All right, let's stop there and we'll come back for another one.